Okay, we got one store that is $76.65 for 3 kgs. The other store is $23.50 for 2 pounds. Which store is cheaper? So, what do you want to do? Everything with pounds or everything with kgs? It doesn't matter at this point. Somebody just pick. What are we going to pick?
Pounds.
Ha!
Pounds.
Okay. Dual. Pounds, kgs? I heard 2 pounds and 1 kg. So we're picking everything in pounds. Okay. So this one we're going to convert then. So 3 kgs equals what? We're going to convert that to pounds. And I know that 1 kg is 2.2 pounds. So I noticed on your test that I do put quite a bit of conversions on there. Okay, so setting this up the same as every time, it's kind of the same situation. So times, divide by 1, which you don't technically need to even do. So that is, should be 6.6, right? Okay. Now I'm going to go into comparison, and I'm going to use unit rates to compare. So 76.65 for 6.6 pounds is how much money for 1 pound? Okay, and the other one is ready to go because it's in pounds, and that's what we said we were going to work with. Okay, so can you try both of them on your own? So convert and then compare unit rates. Okay, on a test, I have the pleasure of basically doubling my answer key because you might do everything in pounds and then you do everything in kilograms. So then for me, I have to have both my answers because you're both going to be right. Just depends on which way you go. And that's fine. Okay, on your test, I'm also awarding points to answering the question. So I haven't even answered the question. Which store is cheaper is my question.
The first store.
So, I don't know, first store. So somewhere you need to make sure you are answering me the question. On your test, it's like half a point deduction if you forget to just write that. So don't want to do that. Okay, 2 racers from different towns want to see who's faster. The first racer had 5 kilometers in 38 minutes. The second one is 3 miles in 0.4 hours. Okay, kilometers, miles, again, pick. What do we want to do? Doesn't matter. Miles. So we're going to do everything in miles is what we're picking. Okay. So 5 kilometers is blank miles. And I don't know, I gave you 2 ratios, so it doesn't matter. $3.1. I can hear it. Okay, also have another problem. The one person timed themselves in minutes and the other timed themselves in hours. What do you want to work with? Minutes. Okay, I like that. So everything with minutes. So 0.4 hours is how many minutes? And I don't give you this on your test. So you need to know this from real life. What do we got? 1 hour, 60 minutes. Okay, so we're ready to go. We changed our 5 kilometers to 3.1 miles, and we changed the 0.4 hours to 24 minutes. We changed those 2 digits, okay? Okay, what is going to make more sense in the situation? Kilometers per minute or minutes to do 1 kilometer? Minutes per kilometer. I think, or mile, that's right, we did miles. I think that makes more sense. So minutes. So the first one, we're going to go 38 minutes for 3.1 miles. How many minutes to do 1 mile? Okay, 12.26. And then the other person, we have 24 minutes to run 3 miles. Okay, I can do this one in my head. 24 divided by 3 is 8. Okay, this is the last part. Answer the question. Who is faster? What's that?
They don't have names.
I know.
Yeah, it's more helpful because it's like.
I think on your test I did things as with names.
Or even like A or B.
Yep. Or you would just probably like circle and point to it and say faster. Okay, graphs. We have a plane. After so and so many minutes, the altitude in feet of the plane is changing. Which interval is the plane descending the fastest? From A to B, B to C, or C to D? C to D. And the reason I'm picking that is because it's the steepest. You don't need to write that, but I'm explaining why I'm picking that. What is going on from the B to C interval? It's a plane that's descending.
It doesn't stop.
It doesn't just stop.
It glides. It's just like.
It's gliding. It's just.
It's not descending at all. It's just like level.
It's just flying level. There we go.
Cause it kind of like drops, right? And it's like.
Yeah, you drop,
It doesn't go like that.
level off, and then you might drop more. Yeah. Okay, so on this question, you have to be careful with the context. The plane didn't stop. Determine the actual rate from going from C to D. How much altitude did this move in that zone? It went from 2,000 to 0, so it moved 2,000 feet. How much time did pass inside that zone of the graph? So we went from 35, right? 35 to 45 on that section. Are we okay with that number? 35 and then D is at 45. So that means 10 minutes. So 200 feet per 1 minute. And I think on your test, I did say, whatever you're doing there, can you please express it as a unit rate, a unit speed? So everything should be per one of something. Okay, you know that you can type 36 words per minute. Your teacher gave you the rest of class, which was 41 minutes and 20 seconds to type 1,000 words. Will you make it? Okay, let's talk about 41 minutes and 20 seconds. That's an awkward thing. What do you want to do with that? It can't be mixing and matching two things going on.
41 point something.
Okay, we can do 41 point something, yep. How do you change that to a point something then?
Divided by 60.
Divided by 60. So 41, and then I'm basically saying 20 seconds out of a possible 60. What is another thing you could have done instead? This works. Just go to complete full out seconds. How would I do that to change it to seconds? I would do 41 times 60 seconds, because each minute has 60 seconds. And then I would add 20 more. Are you okay with what I was doing there? So you could kind of do those strategies on your test. Either way would work. But obviously method one, this is minutes and the other one is minutes, so you're ready to go. If you did this method, you're in seconds. Just change the other 36 to seconds as well, and then you're ready to go. Okay, you pick which way you want. Okay, I'm going to do 36 words per words equals 1 minute. How many words can I type in 41.33 minutes? You also could have done 1,000 words will equal blank. How long? And then compared that time. So you could have done that as well. Okay, so there's lots of options. So like I said, my answer key is just full of a bunch of things because I'm not sure which way you're picking. 36 words. Okay, so here's what I did. I did both ratios, depending on what you wrote on your paper. Just check your numbers that were the same. So are you going to make it? So if I did this person for the rest of class would get in that many words. So yeah, they're going to make it. That's over 1,000. Or if you did it this way, you would say this time it took was less than the class time. So they made it. So answering the question is always part of your answer solution? Yes. Okay. We're going to move on, but I just want to make a very big note to yourself. On your test, I've done this a few times. If I say something like 2 hours and 16 minutes, that's going to be on your test some places. What are you going to do? You're probably going to do this. 2 times 60 is how many minutes? And then add 16 more minutes. Okay, does that make sense? So that's on a few places in your test where you're combining minutes with hours. Okay. The thickness of a coin is 1.95 millimeters. The diagram was drawn with this thickness. What's the scale? Okay, converting. Millimeters, centimeters, we need the same. What's the best to go to here? Should we move everything to centimeters or everything to millimeters? Centimeters? I would have maybe gone the other way, but you can do centimeters. I like going bigger versus going, yeah, or you know what I mean? Because if you change if you change millimeters to centimeters, it's going to be more decimally than I would maybe want. Okay, I'm going to go this to millimeters. Okay. You don't need to memorize this, but I'm kind of hoping you might have it memorized. How many millimeters are inside 1 centimeter? 10. Okay, so we got everything in millimeters. So I need to organize this diagram to real. Always diagram to real. Okay. When I'm reading this, let's label a D and an R. The thickness of a coin is this. What is that? A D or an R? That's a real life coin. In the diagram, it was drawn like that. So 29.25 to 1.95. Which one of those should I change to a 1? The smaller number should change to a 1. Multiply, divide. Okay. A bedroom has a width of 12.5 feet. Guess what? I'm going to put an R over that right away. That's a real bedroom. On the diagram, it's got 18.75 as its width, a diagram. Okay, next problem. We got feet and inches. So, which way are we going to go? Change to inches. Ooh, you got to use your rulers yesterday. How many inches do you have inside a foot? 12. Okay, so there's a conversion. Now let's set it up. Diagram to real. So the diagram was 18.75. The real life was 150. So which number should I change to a 1? 18.75? So the real life is 8 times bigger. Do you notice in the first one, my real life object is 15 times smaller. And in this, the real life object is 8 times bigger than the paper. Makes sense? Because it's a bedroom. The other one was a coin, right? So obviously use your real life thinking. What are you visualizing? The thickness of a coin, 1.8 millimeters. Let's put an R on that one. It's a real life thing. In the diagram, they used a scale factor of 50 to draw it in centimeters. What is the new dimension in the drawing? Okay, so diagram to real life. Okay, think about the coin. Which one is the 50 and which one is the 1? 50 goes on the bigger one. What's the bigger object? The diagram is bigger or the real life is bigger? The diagram would be 50 because the diagram is bigger. It's a coin. Okay. So 1.8 millimeters on the real is how much on the diagram? So you have to enlarge it by 50. Okay. I didn't finish this though. What's the new dimensions? Because you have to do it in centimeters. When you draw it, they ask for how many centimeters. So 90 millimeters is how many centimeters? Some of you, if you're not setting up these proportions because you're just understanding, boom, I need to divide by 10. Times by 12 on the last one, whatever, I'm okay. You don't have to set up a ratio every time. I'm just doing it so you can see what's happening. Okay, a bedroom has a width of 9 feet. So that's a real life. A scale factor of 0.1 was used. I don't like how I wrote this. I don't know. I probably would have wrote this question differently. Do you understand that that's 1/10? Okay. Where are you going to put a 1? Where are you going to put a 10? So 1, 10. The 10 is on the bigger. So what's bigger, the diagram or the real life would be the bigger? The real life, every 1 on the diagram is 10 in the real life. And the real life is 9 feet. How many inches on the diagram? Well, we're going to have to also do some kind of inch work here. So 9 divided by 10 is 0.9 feet. So 0.9 feet is how many inches on your drawing? 1 foot is 12 inch. If you really wanted to impress me on your test and you were like, that is 10 inches and 13/16 of an inch on the ruler. Okay. Let's skip. Let's go to number 10. We have a room that is 20 by 18 feet, and then we got to put it onto an 8.5 by 11 paper. This is like what we did yesterday. We got to get a scale, and then we're going to have to figure out how to draw it on that paper. So let's talk about our real life room. Let's go to inches. Are you okay if I change that to inches right away? I'm going to shortcut it here because I'm understanding my ratios. If you have to do a side ratio, that's fine. I'm just timesing it by 12. Okay, now I'm going to try to be shrinking it, and then I would like to fit it on an 11 inch by 8.5 inch paper. So here's what I'm going to do. I'm going to divide those numbers to see how much bigger. I'm going to divide those numbers. So on the one, I'd have to shrink it almost 22 times smaller, and the other one, I'd be like 25.4 times smaller. Pick me a number that will work to shrink it enough for the paper. What do you have to pick as numbers? You have to be what compared to this? Larger than that, because you have to shrink it enough. So it's better to shrink it more than it fits onto your paper. What do you want as a number? 28, 30, 29, 26. Those all work? All work, okay? Those are all fine. So your answers on your test, they're all going to vary. That's okay. I'll figure out your answer. Okay, I'm going to use the 30 number. So diagram to real life, I would write it 1 to 30. Okay, here's why I picked 30, because I am dividing 240 by 30, which makes a nice 8 inches. So when I can put that on my paper, that fits nicely, the 8 inches out of the 11 on that side. And 216 divided by 30 is 7.2. So that's nice. It fits onto my paper, that. Okay? I did 240 divided by 30. Here's basically what I did in the long way. There, that's what I did, Reese. 1 to 30 would be what to the 240. That's why I divided. Yep. 1 to 30 would be what to the 216. Yeah. Sorry, yeah, I kind of skipped that step. I just knew I needed to divide it to make it smaller. Bless you, bless you, bless you. Okay. You had a picture frame that was an 8 by 12, and those dimensions got tripled. What is the new area? Okay, what do you want to do here? Do you want to figure out what is the area of an 8 by 12? Is that 96? Somebody did it on their calculator? 96 inches squared. Okay, the dimensions were tripled. What number is that? Tripled is the number what? 3. What scale factor am I talking about? So remember we had linear scale factors, area scale factors, volume scale factors. The dimensions have tripled. So that is my just linear. That's how my linear is changing. So my area scale factor would be what then? If the sides change 3 times bigger, the area would change 9 times bigger. So the new area would be 96 times 9. I feel like every time I've done these, I kind of section it into 3 chunks, right? Like, okay, painting a mural on a wall. Oh, look at that. 12 by 8 again. Using an overhead projector. If the original sketch had an area of that, what is the scale factor? Okay. Ooh, I don't like this question. We got feet and inches squared, so that's not good. 12 feet is how many inches? 8 feet is how many inches? Okay. So I'm going to do the area on the wall projection. Projection area equals, I'm going to do 144 times the 96 because I'm working with inches. Okay, ready? This is what we've always set up. New over original. That's what we always talk about. It's always that way. New over the original. So the projection area over the original area. But did you see all the work I had to do to just make sure everything's lining up at the same units? So the area on the screen was 64 times larger. I would like to label this. What 3 letters should I use? Area scale factor. That was my areas. So what's the scale factor on how the sides are changing? I want the linear scale factor. So now how do I go back from area to linear? The square root. So last time, remember here, we went from linear to area, we squared, now we square root, going back the other way. So the linear scale factor is 8. Okay, a couple more questions and then we're done. Oh, there's still another page. A circle diameter 56 centimeters is reduced to 7. Determine the scale factor for the areas. I think this is the very first question, but everything is centimeters, centimeters. We don't have to do anything to convert. Okay. Which one of those would I consider as the new object's size? 7 is the new one because it got reduced to 7. So 7 over 56. Can I label that? What SF? Is it the linear, the area, or the volume? It's L because it's a diameter. A diameter is a linear measurement. So the area scale factor is what I want. So I would square that number. I don't know. I'm just going to write it all out because it did terminate, so. Ooh, 2 questions in a row I see with the same units. No conversions. The area of the first rectangle is 900 centimeters squared and the second rectangle is 10. So let's do a new original. The new, I think we're going to consider the area of the first rectangle as the original, and then the area of the second rectangle would be the new one. So 10 divided by 900. What kind of scale factor was I talking about there? That was the comparison of the area scale factor. So how do I go from area to linear? Square root. And do you notice how I'm putting these dots? To me, that's saying I have it on my calculator. I haven't taken it off. So it's still on there, and I'm going the square root of the answer button, because then you don't have to do any rounding, which is nice. I usually just do 2, but this one was just, you know, that 5, so close to being in the middle. Okay, couple left. I think we're probably going to tackle some volume here. A water bottle has a volume of 16 ounces. For the drawing, a scale factor of 0.4 was used for the dimensions. What's the new volume? Okay, so here's what I know. 0.4 was the scale factor on the dimensions. So that's just the linear stuff. The height of the bottle. So, what is your volume scale factor? What do you do to go from linear to volume? What do you do with that now? Cube it. So we went from squaring, now we're cubing. Okay, linear volume. Now what's the new volume? 16 ounces times 0.064. Okay. Ta-da, the end is in sight. Okay. Centimeters, I'm always double checking. Centimeters cubed, good. Volume of the first, volume of the second. So I'm going to do one of the new divided by original strategies. So the second cube is the new one, divided by the original. Okay. I would like to label that number as something. What is that telling me? What was I comparing here? Those numbers were the volumes. So this would be the volume scale factor. What is the scale factor of the sides? So what is the linear scale factor? So what am I going to do to go from a volume down the scale to a linear? Cubed root. Are we remembering that button? Do you remember where your own button is? Because everybody's is a little bit different. So the dimensions on this cube, the side lengths are 1.4 times bigger. Adriana, do you have that button on your calculator? Okay. Did you forget where your button was? FYI, on a test, let's say you're just like, I don't know where this button is, just call me over. Anything calculator related, I will help you with your buttons. Okay, good? I think we'll end there.